Thank you, everyone, for coming to my talk this afternoon on critical elements in New Zealand. I'd like to thank my co-authors, James Pope and Shapong Dai, as well. So let's get started. So what's the key points of the presentation? Well, the purpose of my talk here today is really it's a preliminary look at some previously published data from the perspective of critical elements. The data strength is that we've got a wide coverage across New Zealand, many of the coal occurrences, 14 in fact. Now, there are limitations to the data. We only looked at trace elements, not at rare earth elements, because at the time that was not what we were interested in. Plus, the data is 17 years old, so there's some things that were probably left out. So why New Zealand? Well, it's a small country with an outsized world voice for environmental activism. That is, it's small, but it has a global following. Also, although New Zealand promotes a green economy, there is the little actual economics supporting the world's transition to a sustainable energy. So their voice is loud, but they don't necessarily have too much skin in the game, as we say. Now, much of New Zealand resources have to be imported using traditional fossil fuels, leaving its economy open to outside influences. So what we're thinking is that if locally sourced critical elements were to be economic, this would allow New Zealand to create its own green economy, and it would finally be able to actually participate with other countries in the global energy transformation. So let's look at the sites. Now, as I said, there's 14, but we're only going to concentrate really on these three here, Stockton, Mount Frederick, and Island Block. But throughout the whole sampling area, it does cover quite a good range in age and rank. So the Miocene is shown in the green blocks, the Eocene in the red blocks, and the Cretaceous in the blue block. So only Cretaceous in the South Island. It has a good rank distribution, all of these samples, from lignite to bituminous, but all of the three main areas that we're looking at, which is Stockton, Mount Frederick, and Island Block, are bituminous in rank. Lots of critical elements. We can't cover them all, but the ones that we will cover are lithium, cobalt, gallium, germanium, and antimony. Now, I chose them for a variety of reasons. One is that they are actually fairly abundant in the areas that we are looking at, but they also all have end uses. I'm not going to read out every one of these, but a lot of them either has to do with rechargeable batteries, especially lithium, or in solar panels, or integrated circuits and alloys. And of course, we all have one of these, and we may have two or three of them at any particular time. And they're just packed full. They're a gold mine of critical elements. And actually, three of the ones that we're highlighting here, lithium, cobalt, and gallium, are found in almost all smartphones. Now, again, we didn't look at rare earth elements, but this is what's driving a lot of all the critical element mining. And so you can see that it was pretty much dominated by the US up until about 1980. And that's about the time that the digital world sort of took off. And the rare earth elements are almost solely sourced from China at the moment, although some areas are growing. That also coincides with when Tim gets his first personal computer, an Apple IIc, actually, if anybody remembers that one. And a lot of things were happening in New Zealand between the end of the Cretaceous and Paleocene. Mostly it was being inundated with seawater. But even during all of this time, there was always non-marine type sediments, and actually plenty of coal deposits or paleopeat deposits accumulating, even in the maximum inundation, which was in mid-Oligocene. Okay, so let's look at the critical elements, the 5 critical elements in particular in our 3 areas. First, the Stockton Plateau. So lithium is over 20 times the background for coals based on Dye et al. 2020 and Ketris and Udovich in 2009 on a whole coal basis. Cobalt is about 10 times normal background. Gallium about 9 times. Germanium about 80 times the normal background, and antimony even higher, well above 100 times. Mount Frederick, similar pattern. Very high concentrations in lithium, also cobalt, which is about 30 times the normal background. Gallium is a bit less, but germanium is even higher, really well above 100, and antimony, again, is quite high. The final area, which is Island Block, all of them, by the way, they're in that northeast part, remember, northwest part of the South Island. Still high lithium. Cobalt is smaller. Gallium and germanium is also smaller, but still significantly above the normal coal background based on whole coal, and antimony is still high as well. So why might this be so? Well, we do know that in this area, that's all those three data points were from this area. There's lots of felsic intrusives. Cretaceous age, yes, but the coal-bearing units are all lying near or on top or lateral to these exposed surfaces. Plus, at the time, there was still a lot of things going on. There was during the Eocene, during the deposition or accumulation of the Paleopeat in rift valleys, grabens, then with compression, things were uplifted, lots of pushing and shoving, and other events that are taking place that allows contact and movement of basinal fluids. Finally, this cross-section from Flores and Sykes, which shows the coal in black here on top of the felsic granites and some metamorphics as well. And of course, they're right in contact in some cases, but in other cases, they're exposed, and that is the source rock for some of the inorganic sediments. I like this graph. Essentially what it is price on the y-axis versus abundance of elements, and what it's trying to convey is the relative commerciality, essentially, of elements based on, of course, the current price, and this comes from Hurd 2012, so it's a little bit out of date, but it gives you a feel for it. If we plot our numbers on here, our elements, that is, with today's current prices, you can see that they're all above this lower line, which essentially means it's at least marginal to good, possibly economic quantities being able to be extracted, especially in our case, germanium and gallium. So what does all this mean? Well, there's some high on whole coal basis critical elements in many of New Zealand's coal deposits. And I've only shown you 3, but it's throughout New Zealand as well. Germanium in particular in that Buller area that we discussed, it's indicative of a coal-hosted germanium ore deposit. If so, we might be able to extract it. The element assemblage is also very similar to others that are being mined in coal-hosted germanium deposits, for example, in Linkang and Wollongong in China and Spitzjuli in Russia. Now, the Buller coal is characterized also by elevated beryllium, uranium, and particularly arsenic and antimony. This is typical for a germanium host, or a germanium deposit, which is hosted inside coal. Although rare earth elements were not analyzed, it is highly likely that they'll probably be enriched too if this area is like other high critical element coal deposits. Finally, we don't know about the economics. We haven't really researched that. But if it is favorable, it may just allow New Zealand to participate, not just discuss, the global green economy transition. And here's some references that I cited during my talk, and let's have a discussion. Thank you.